Assalamu alaikum. This is the practical session for our experiment, full voltage control of a three-phase induction motor. The three-phase induction motor in our experiment right now is the squirrel cage induction motor, which is this one. Now, if I want to run a motor without control, just run it, I'll have to connect 1, 2, 3 of the power supply to 1, 2, 3 the coils of the motor. Then the other terminals of the coil will be shorted together. Now, if I start the motor, or if I start the power supply, the motor will start running. Now, I want to put a control in the circuit. I want to control the circuit. Right now, I have only this breaker to control it. There is no indication of anything, of any control. So, this is the control circuit of the squirrel cage. I have the power supply 1, 2, 3 coming from here, going to the circuit breaker. So going to 1, 3, 5 of the circuit breaker. This is the circuit breaker. From the power supply, okay, from the power supply, 1 going to 1, 2 going to 3, 3 going to 5, and coming out from 2, 4, 6. 2, 4, 6. This switch will make the connection on or off, depend on your choice. Now, from 2, 4, 6 of the circuit breaker, we'll go to the 4-pole contactor. This is the normally open contact. So from 2 to 1, from 4 to 5, and from 6 to 9. This is the contactor, okay? This is the normally open contact, and this is the normally closed contact. I have to choose 3 normally open contacts of the contactor. So, doesn't matter if I choose this one, this one, this one, or this one, this one, this one. I have to choose only 3. So, from 2 to 1, from, make it easier, from 2 to 1, which is this one, 1, then from 4 to 5, which is this one, and from 6 to 9. Then from 2, 6, 10, from 2, 6, 10, which is this contact, to the overload relay, 1, 3, 5. 1, 3, 5 of the overload relay. Okay? Then out of the overload relay, this one, you can see the contacts here, up. From 2, 4, 6 to the induction motor 1, 2, 3, which is the machine that we have. Now the power circuit is finished. The control circuit. In the control circuit, I have to choose to take 2 wires from the wire that is connecting 2 of the circuit breaker and 1 of the contactor. So I'll take from 1 and 5, from 1 and 5 of the contactor to a transformer 3 and 6, which has a rating of 208. So 3 and 6, I will connect 1 and 5 to 3 and 6 because the total is 208. So the 2 wires will come here, 3 and 6, and it will go out from 1 and 2. This is the start push button. We've used 3 and 4. This one, 3 and 4, which is normally open by default, unless if we press the start push button, this one will go down to connect both of these. So normally no connection, and 3 or 4, no connection, no connection, because it's open. But if I press this one, the connection will come. If I release my finger, the connection will go. So 3 or 4 is open by default, so nothing happened here, unless if I press the button, then the connection will come. This breaker, the same thing exactly. I have 1 or 2. I have 1 or 2 here, 1 and 2. There is a because it's on. If I turn off the breaker, the connection will be gone. The contactor follow the same way. I have normally open contact, so 1 or 2 is normally open, 1 or 2 normally open. Okay, 1 or 2 normally open. There is no contact unless current pass through the coil, which is 1718, and this one will go back. So if the current pass through the coil, here, this one will go back, and that normally open will be normally closed. The same if I use 3 and 4, it will be directly connected, okay, because it's normally closed, and it will remain as it is unless current passed through the coil 1718, and this one will go back, and if this one goes back, this one will be normally open and the sound will not appear. So whenever the current passing through the coil, okay, this one will be changed to normally closed, and this one will be changed to normally open. If I press this coil, if I press this push button, the current will pass through the coil, and this one will change to normally closed, so the current will pass through the motor and the motor will start running. If I put stop push button here, I disconnect the current going through the coil, through this one and this one, so this one will return to normally open and the motor will stop running. I'll start making the connection. So from 1, 2, 3 of the power supply, 1, 2, 3 to the 1, 3, 5 of the contactor. Then from 2, 4, 6 to the contacts of the contactor, which is 1, 5, 9. So from 2, 4, 6 to the 1, 5, 9 of the contactor. Then from the 2, 6, 10 of the contactor to 1, 3, 5 of the overload relay. So from 2, 6, 10 of the contactor to the overload relay, 1, 3, 5. Then from the other terminals, 2, 4, 6 to the 1, 2, 3, the starting coil of the squirrel cage. Then this one will be shorted. Then from 1 and 5 of the contactor, or 2 and 4 of the circuit breaker, to the 3, 6 of the transformer. I took it from here, of the contactor, 1, 5, this one, it will go to 3 and 6 of the transformer. From 1, it goes 2 wires, 1 to the green light. This is 2 wires, 1 to the green light. The other one is to 3 terminal of the push button. So this is, we will consider it the start push button. from one of the transformer to the green light, and the same from one as well to the 3 of the push button, both of them from one. Now from 4 of the start push button to the terminal 17, the coil of the contactor. So from 4 to 17, from 4 push button to 17 of the contactor. Okay, then from 18, the coil of the contactor, to 8, the normally closed overload relay. From 18 to 8, the normally closed contacts. Okay, then from the green light to the other terminal of the green light to 9 of the overload relay. This one, we've connected this one to 1, if you remember. The other one is to 9 of the overload. And from 7, the overload relay to 2 of the transformer. From 7, the overload relay to 2 of the transformer. Then I have to connect the red light in parallel to the 17 and 18. The red light will be connected in parallel to 17, 18 of the contactor. Now, if I close the circuit breaker here, this one, if I make it on, nothing will happen. Why? Because this is a normally open contact, so the current will not go passing this contact. It will stop here. Okay, in order to make this contact normally closed, I have to energize this coil. So by energizing this coil, I have to press the start push button. If I press the start push button here, the current will go through the coil. The coil will be energized. This one will go down. Okay, and this normally open contact will be normally closed. Then the motor will start. So I will press this one, start push button, and this coil 17, 18 will be energized. This one will go back and the motor will start running. But whenever I release my finger from the start push button, the motor will stop. Why? Because if I disconnect the circuit here, the current will stop passing through the coil, and this coil will be de-energized, will go back to its original place, and this one will be normally open, so it will be open circuit here, and the current will stop passing this contacts to the motor, and the motor will stop running. So how can I solve this issue? Whenever I press this one, the motor will start. If I release my finger, the motor will stop. And you can see the indication here. Whenever this coil is energized, the red light will be on. Look. To solve this issue, I have to put 13, 14 or normally open contact of the contactor. This one is M contact, okay, in parallel with the start push button. So if I press the start push button, this one will be energized, okay, and this one will be turned to normally closed, okay. If I release my finger, this one is still normally closed because the current will pass through the contact and still energizing the contactor. and it will not stop. So even if I release my finger, the current will still pass through this branch to feed the contactor, and the motor will continue running even if I release my finger from the start push button. This is the contactor. This is 1314, normally open contact. This one, 1314 of the contactor. Okay, it will go directly in parallel to the 3 and 4 of the start push button. So now, if I press the start push button, the motor will start running. If I release my finger, nothing will happen. The motor is still running, and this one is still energized, and the lamp still on. Now, how can I stop my motor? The only way to stop my motor is by disconnect the circuit breaker here, which is this one. So this is the only way I can stop the motor. This is there is no stop push button. We didn't use it. So in order to use it, okay, if I want to stop the motor, I have to place the stop push button here before the holding. So the current will stop at the switch, like this one. So if I press the stop push button, it will become like this, and the current will stop here, will stop at this terminal, and it will not go through the coil or through the start push button. So the connection will be from 1, okay, instead of going to 3, it will go to 1 of the stop push button, and from 2 to 3. So the connection here will be different. From 1, it will go to 1 of the stop push button, and from 2 to 3, this one. So from the transformer 1, instead of 3 of the start push button, it will go to 1. Okay, return this back to 3 to 1, and from 2 the stop push button going back to 3. Now if I switch in the breaker, press the start push button, the motor will start running. If I release my finger, nothing will happen, still running. Now I can disconnect the circuit by pressing this switch. Starting, stop. This is the connection, the overall connection. Thank you so much.